Hello everyone and welcome to my channel, and today we're going to continue programming this part. And the first features I want to machine are the fillets around the cutout. So let's program this first fillet here, and I want to show you different methods of tool axis control during the cut. So the thing I want to create before I start setting the operation is I'm going to create some lines that I'm going to use for tool axis control as tilt lines. And to keep things organized, I'm going to create a new level, and I'm going to call it tilt lines. And I'm going to show you quickly how easy and quick it is to create those tilt lines. So navigate to wireframe, and in the line section, line closest drop down menu, select line normal, and it will create a line normal to the surface at the point. So click on the surface first, one left mouse button, and as you see, the arrow represent the line that is going to be created and its direction with the base point on the surface. So my first tilt line will be exactly in the middle of this surface, of this edge. So drag the mouse until you have a snap point, like you see the line with the cross, and click left mouse button. The second line I'm going to create on the other edge, and on this edge I'm going to create a line on the midpoint as well. Now I would like to have a line somewhere here in the middle, so I'm going to find the midpoint of the top edge, and without clicking I'm going to stop the mouse cursor above this snap point, and it will leave a green mark, like a green cross. I'm going to do the same on the bottom edge, and I'm going to drag the mouse button until I have a snap point, and I hold my cursor above this point, and as you see, Mastercam created midpoint between those 2 points that I left. Now let's create the line here. Okay. So these are going to be used as my tilt lines. So now let's quickly go to Multiaxis gallery and select MORPH. So first thing I'm going to do is I'm going to bring the settings from my default file. So it's going to be all default settings. And my tool, I'm going to use 3mm ball nose. In a cut pattern, my pattern from, I'm going to use a curve, and I'm going to select the top fillet. And its top edge as my pattern from. Pattern 2, again top fillet, and I'm going to use its bottom edge. Okay. My drive surface is going to be each face of that fillet. And I'm going to select the area type as full start and end at exact surface edges. So it's gonna cut first and last cut at exact edge of the surface. I'm not going to leave any stock, and I'm going to use 0.15mm of step over between each pass. Okay, all those settings looks okay. In advanced option for surface quality, I'm going to select exact. And in parameter for surface edge handling, I'm going to do extend edge curve. In the tool axis control, I want my output to be 5 axes, but the tool axis control, as I mentioned, I'm going to use lines. And all lines weighted by the distance. This is what I want to use. Now we need to tell Mastercam what lines I want to use for my tilt lines. So press the arrow button next to the tool axis control, and line tool axis control window will let you to choose lines in 3 different methods. You can select one by one line. So remember to point the arrow in the way of retraction, so away from the surface. Okay, in our case, arrow shows the direction of retraction. If you want to cancel any of these lines, you can select this cancellation button and deselect it, or you can change the direction of those lines by using this reverse button. Okay, in the collision control, I'm going to change that to retract tool along the tool axis. Okay, now I'm not going to change anything here. In the linking, I want my default links, small gaps, to be on direct. And those small gaps is going to be every gap below 5 millimeters. So anything below 5 mil value is going to be considered as a small gap and is going to be direct. Okay, link. My clearance area, I'm going to use standard for this job, cylinder, x-axis, and 70 millimeter radius around the part is, around the axis actually. So it is cylinder 140 diameter. It's going to be my clearance area. And my planes are top. So let's go and have a look. The toolpath. Okay, so this is our toolpath. It looks good. Yes. Okay, so let's quickly go and backplot the toolpath and let's see how the tool actually tilts during the cut. And as I mentioned, the tool aligns itself with each tilt line that you select, and you can have as many tilt lines as you want. And it is a very easy way to adjust the tilt. So for example, let's say that you want to avoid something on the right hand side. Simply select one of the lines that's close to the obstacle, and then select the dynamic. Place the genome at the base of the line where it touches the surface. Click left mouse button, and now just adjust your tilt to your needs. Just to show you guys, I'm going to use very big tilt. Okay. And now to view the result, you don't even need to go back to your operation. Just regen the toolpath and Mastercam will recalculate the tilt and the passes. Of course, the line that you adjust, it needs to be one of your tilt lines that you selected in your tool axis control. So as you see, it's easy. Even when you have your toolpath ready, it's easy to adjust the tilt along the cut. Okay, I'm going to undo my adjustment, and that's cool. With my next operation, I'm going to finish this bottom fillet on the same wall. So I created a new level, tool axis control 2 point, and I'm going to use different tool control. Okay, tool axis control. In wireframe tab, select point, place the point on the mid section of this edge here. Okay, select OK, and now select this point, just click left mouse button on it, and you have a dynamic option here, okay, in the suggestion tab. Or you can just simply go to transform and select dynamic from the transform tab. Place it on the point, okay, and now I want to offset this point in Z direction 50 millimeters, and now in X axis direction I'm going to offset this 55 millimeters. Just simply click on the X arrow and drag it to the left. Accept the settings. Of course, method is move, and the point is moved to new location. So let's go and select our next toolpath. From the multi-axis gallery, I'm going to select MORPH again. I'm going to use default settings, and in the tool I want free mill, cut pattern page. I'm going to select the top edge of this fillet, starting from here, okay? And I'm finishing here. As a pattern 2, I'm going to select the bottom edge of this fillet. Okay, and now my drives, those 3 faces, making that fillet, and I don't want to leave any stock, okay? This is all fine, but I'm going to change the type of area to determined by number of cuts, and I want to cut it with, let's say, in 5 cuts. Advanced option, I'm going to use approximate and the slow and safe path creation. And in tool axis control, this time I'm going to select tool axis control to point. Okay. And with the arrow button here, I'm going to select this point we just created. Wrong. Point. Okay. And in this way, my tool will be pointing towards this point in every position. Okay. I want to change that to retract tool, sorry, along the tool axis. And in linking, just set our clearance area 70. Okay. So this is our tool path. Okay. So the tool is pointing towards our point. So you see, in every position, it will keep focusing or aiming towards this point here. And if you want to do a small adjustment for the position of the point, just click on it and use transform option exactly the same way as in the last operation. Next feature we are going to cut is the top fillet here, okay, around. And I want to use some limits because I want to keep my tool in vertical position. I don't want the tool to tilt to the front side of the part or to the back. I don't mind Integrex to rotating on the Z-axis while it's cutting this area, then switch to that side. But I want tool to be kept in the vertical position. So we're going to use some limits. So let's go to multi-axis toolpaths, select morph again. We're going to use 3mm ball nose. In the cut pattern page, my pattern from is going to be curve. And of course, I'm going to select the top edge of this fillet. Okay. My pattern 2 is going to be bottom edge of this fillet. Okay. And my drive surfaces, the fillet that we want to cut. Okay. And the area type, I'm going to change to full start and end at exact surface edges. So from edge to edge. Point 2, step over between passes. Tool axis control, I'm going to change that to surface with tilt. But as I mentioned, I'm going to use limits. In the limit subpage here, I'm going to use conical limit, and because our part is on the x-axis, here, I want my cone to be on the x-axis. And as I said, I want the tool to be vertical position. So basically from 80 to 90. I can give it a little bit of a freedom, 10 degree if it needs. Okay. So this is our toolpath. And look at this. Our tool will be kept in 90 degree. Okay. Okay, with our next toolpath, we are cutting this bottom fillet. So let's go to Morph toolpath and multi-axis gallery. We're going to use 3mm as our fillet is 1.7 millimeter. So this one is 1.5. We don't need many cuts. So I'm going to set that straight away to determine by number of cuts, and I'm going to use 5 cuts only. Okay. I don't even need as much, but let's leave as 5. So my pattern from, I'm going to select curve and the top of this fillet, pattern to bottom of this fillet. Our drives are going to be those faces that create the fillet. I don't want to leave any stock, and approximate slow path creation, extend to curve edge. Okay, extend the edge curve, and in the tool axis control, I'm going to leave those as they are. Okay. That shouldn't be my tool hitting that face, but just in case, we can add some collision control, and let's tilt the tool to the side if we hit anything from here. Okay, So anything on that face, we will tilt the tool. But it shouldn't be any problem with this because the face is actually opened a little bit. Okay, that's fine. So this is our pattern. Okay. I'm going to change quickly one thing. I don't want that retraction here. So I'm going to go to Lincoln and change that to value. And let's say 10 mil. Now we have the whole cutout finished. Okay. Before we move on to next operation, let's quickly see the back plot of this toolpath. Okay, I'm happy with the tilt. Yes, the side of the tool is being kept away from the side of this cutout. Okay, and with our next toolpath, we are going to machine or program machining of the external fillet that goes around the part. So for that, I'm going to use MORPH toolpath from Multiaxis gallery again. And I'm going to bring my default settings from default file. Okay. So let's go back to tool page, and I'm going to use this time 6mm ball nose end mill. And in the cut pattern page, I'm going to use a curve as a pattern from, and let's select the external edge of that fillet that we want to machine. Okay. Hold down. Okay. Change direction here. Down. And we finish here. Okay, so this is our pattern from external edge of the fillet, and as a pattern 2, I'm going to select the other side of this fillet. This way. No. And go back here. Okay, so this is my pattern 2. And drives. So I want to cut this whole entire fillet that goes around the part, including the small pieces here. Select the whole fillet. Okay. All looks good. So now I want my step over to be 0.25mm between passes, and my cutting method, I want to go one way. Okay. That's okay. In advanced options, for surface quality, I'm going to change the method to exact. And in the tool axis control, I want my output to be on 5 axes. Tool axis control to be surface with tilt. I'm going to leave those at 0 and 0, but I want to use limits just to avoid the wall of my multitasking machine on the left hand side. I'm going to add the conical limit on the x-axis and my maximum b-axis tilt to be 90 degrees, even 85. Okay, Let's go to collision control, and I don't want to trim my toolpath, okay? I want to use tilt for all part of the tool, including flute, shoulder, shank, and holder. And instead of leaving drive surfaces, I'm going to use check surfaces, and I'm going to select entire holder, triple click. Okay. I'm going to leave that as automatic, but for the collision control number 2, you have number 2 extra settings here, and I want to change rotary to X. Okay, I'm going to leave this as equal tilting at the moment, but if I have any trouble, I will change it to rotary tilt. Okay, and I'm going to add another collision control strategy just for the tip. Activate level 3, remove the shoulder, retract the tool as a strategy, and as a parameter I'm going to leave along the tool axis. Unselect drives and check surface. I'm going to triple click on that as again to select the whole 3D model. And let's go to linking. I'm going to change my small gaps to be direct and the large gaps to be direct as well. Okay. Clearance area, I'm going to change from plane to cylinder on the x-axis. Okay. Additional settings, planes. I've got top and top and top. And let's have a look at the toolpath, and if it's something wrong, we're going to do some adjustments. So I added the tilt because if our tool is in that position, we would hit the part, okay? So to avoid the collision, Mastercam will tilt the tool. And this is our toolpath, okay? So all looks good. Let's quickly run backplot. Even somewhere here. And of course we have a video of cutting this part, so don't forget to check the video as well. Okay, so in our next step we are going to cut those blends here, okay, on both sides. So I created another toolpath group, and all those 4 blends I'm going to put the toolpaths in this group. So let's go to Multiaxis gallery and select MORPH. I'm going to reload the default settings from default file. In tool tab, I'm going to select 6mm ball and mill. Cut pattern, I'm going to use pattern from curve. Okay, and let's start with this one. So my pattern from is going to be bottom edge. My pattern to is going to be top edge. My drive is this, and I want to cut zigzag 0.25mm step over between passes. You can leave an approximate, but I prefer using exact in most of the cases. Tool axis control, I'm going to leave this as it is at the moment, and the only one thing I'm gonna change is the tilt angle, and I want to be on the -25. Minus means that my tool, this is my pattern from edge, my pattern to is here, so if it's a minus, it will tilt the tool towards the pattern to. If it's a plus, it will tilt it away from the pattern to. Okay. linking parameters, I will use cylinder on the x-axis, 70 mm radius, and my small gaps and large gaps I'm going to change to direct. I don't want any retractions. Okay, so let's have a look at the result. This is our toolpath, start, finish. Okay, one thing I'm going to change is in the pattern, cut pattern, I'm going to extend and trim. Okay, go to extend and start as well as end. I'm going to add 2 mm. And let's regen the toolpath. Okay, that looks good. So I'm going to copy this and paste. Okay. And now I'm going to just reselect my two things, my patterns and my drive. Okay. So actually 3 things. So pattern from, because I want to tilt to the right hand side towards this edge to keep the tool away from that side. So this is my pattern from. Pattern to, and my drive is going to be this. So as I said, when it's a minus, it's tilting towards the pattern to. So it tilts the tool that direction. Okay, that's great. This is what I need. Now let's do the other side. So we're going to select this edge first. Remove, 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 and now pattern from, I want to tilt towards me, so that's my pattern from. Pattern to, and my drive. Cool. Copy after, and here I'm going to change again my patterns and my drive. So my pattern from is here because I want to tilt. I've got the minus 25 degree, so it will tilt towards the right hand side, towards the pattern to edge, and my drive is that. Okay, let's regender the operations. So this is my pattern to edge. That's good. This looks good. The next feature we are going to machine is this pocket, end pocket. So I created a new toolpath group, finish end pocket, triangular mesh, and we will use triangular mesh to finish this feature. First we start with the flat area, and then we will program this undercut here, pre-finish and finish that, and then we go to the other side and we pre-finish and finish this side of the pocket. Okay, so I've created a stock model, and basically it is just a stock model with all the operations processed. and this is my 3D model, and we'll be using that for the simulation, so we can use this stock model and simulate from this stage. Okay, so let's go here, select our stock model, and this is our stock model that we're going to use as a start for simulation, as a material for simulation. Okay, so let's go to our multi-axis gallery, and in the pattern section select triangular mesh, and I'm going to use 5mm flat end mill. We don't need a long series, but I had this assembled, so I selected this one. Okay, stock, we won't be able to use the stock for the pattern that I want to use, so let's select flat lands. Okay, flat lands. So as I said, stock model is a stock option is not available for that pattern. So in here you select your machining surfaces, and I'm going to triple click the 3D model, and I've created also in the surfaces fill holes, so I'm going to add those fill holes because I want to have one constant nice pass. Okay, and you have two types you can select, offset or dynamic, and I want to use dynamic. Offset type is the method how you leave the stock on your 3D model, and global means you have the same offset on the side walls and on the floors. And if you switch to radial and axial, radial is your side walls and axial is your floor. Okay, I'm not going to leave any stock, I'm going to finish this floor. Okay, we've got already it roughed, so I want to just finish it. And of course you can, as a standard, you can use containment, and you can filter out small faces, so flat areas smaller than 1mm will be filtered out. We won't machine those, but I'm only going to finish one face on the bottom of that pocket. So I'm going to leave those options as standard settings. I'm happy with those. You have two cutting methods here, zigzag and one way. I'm going to use zigzag and climb. Okay, so let's have a look into sub pages here. So advanced options, I'm going to use output as output type to fit arcs, and I'm going to give a 0.5 arc fit factor. So there is another group of settings that will appear a bit later, or if we leave and go back, it will appear here. So you can add minimum distance between points and maximum distance, and I'll go through everything later on. So dynamic holder collision avoidance, I'm going to check my holder against the sides and faces, okay, all the machine surfaces, and I want to keep 1mm away, so that's your clearance. You can set the distance, how far you want to keep the holder away from those surfaces. Heights, you can set automatic, so Mastercam will calculate your max and min Z value from all those faces, machining surfaces you selected here. But I want to use user defined, and I want to have a range between -5 and let's say a -30. Okay, so everything between this depth is going to be machined. Machine direction, I will use other direction, and you can have different method of selecting your plane, your cutting plane. And I want to base my cuts on solid face. When you click solid face, you select the face you want your cuts to be parallel to, and then you have option to change the direction of your genome. Okay, so I want my Z to be pointing away from the cutting surface, and X and Y, I don't mind what way it's going to be. So I'm going to click OK. And the tool axis control. So basically, the different patterns, you have different methods, and some of them are 4 axes, some of them are 5 axes, and some of them are 3 axes. This particular one, we do not have a choice. We have just a 3 axis pattern. I'm going to select machine direction and the collision control. I'm going to leave this, and maybe I will add report collision. So at the end of the toolpath generation, we will get a collision report if there are any collisions or it's collision free. Okay, that's fine. And linking. Clearance area is, of course, it's a standard setting like for multi-axis toolpaths. And at the moment, after the cut or approaching would be on the plane and Z axis. So it would, after the cut, it would retract away from the surface and then go up because the Z is pointing up. Okay. If I change it to Y, it would retract from the face and then go to the left because Y is pointing that way. And of course we can change it to machine direction. This is what I'm going to use. Okay. I want to change few things here as well. This is fine. Gaps along the cut. I'm going to change that to direct. Next setting page is linking between passes, but at the moment we have only one pass, so nothing here is available to set. And linking between slices, I'm going to change that to direct as well. Okay, I'm going to leave roughen as default settings, and you have some advanced settings here as well for smoothing and if you want to filter areas, you can filter using the inscribed circle, and diameter will be used for eliminating the features or filtering out the features. Or diagonal, it's like a square pattern, and imagine size between two corners. So for example, if I use 10, it is 10% of the tool diameter. You can use 100, 200, 1000, depends what you want to filter out. Okay, I'm not going to use this filtering. I've got only one face to machine. Utility, I'm not going to change anything here. I don't want to transform my toolpath, as well as I don't want to set any feed rate control zone around the part. And axial shift, I'm not going to use any axial shift as well. In the mesh part, in the additional settings, I'm going to change my plane, and I want to be on the top as a coordinate system, and on the right as a tool plane, and the construction plane also right. Okay, so let's have a look at our toolpath. So we do not have anything here. I'll show you guys something. Let's see the toolpath. Okay, so this is the collision report, no collision found. When you click OK, the toolpath will appear. Okay, so this is our toolpath. mice. Okay. So with our next operation, we are going to cut this area here, including this undercut here. Okay. And again, I'm going to use triangular mesh, but this time I'm going to use pattern called geodesic. So let's go to Toolpaths. In the pattern, select triangular mesh. And I'm going to bring my default settings from default file. Okay. So let's start from tool, 3mm ball nose. And in the cut pattern, I'm going to select geodesic. And my machining surfaces are my drives. So what I want to cut. So I want to cut all that. Including this small face here on both sides, okay? And now we have two types. Offset, it looks more like parallel. So our toolpath would be parallel either to the containment, or if we select the output pattern, to the drive curve. Okay. But I'm going to use MORPH, and I want to blend my toolpath from one drive curve to another. Okay, to the second one. And again, Mastercam can generate the toolpath based on your containment, or I can manually show Mastercam what are my drive curves. So let's say my first drive curve is going to be this bottom edge of this whole feature, and my second one is going to be this. Okay. And you select both curves in the same group. Okay, so select one chain and then select the second one straight away. So you can tell how many cuts you want. You can leave some stock. You can select your tool containment boundary. And the sorting and step over, this is typical for our multi-axis toolpaths. So I'm going to change that to 0.3. Okay. In advanced options, I'm going to fit arcs on any plane. Okay. Machine direction, I want other, and I want to select a solid face. So I'm going to work on that plane. Okay. And when we go back later on here, we will have additional settings that I'm gonna use, like a maximum point distribution along the pass. Okay. So in the tool axis control, I'm going to leave output as 5 axes and surface with tilt. And I'm going to change that to follow surface ISO direction. I want to minimize the B axis motion, so I'm going to use limit. And my maximum tilt is going to be 45 degrees. So from 0 to 45, okay? And con in the x-axis. So it is conical limit from 0 to 45 on x-axis. Collision control. I don't want to use trim, so I'm going to change this strategy and I'm going to go for retract tool. And I'm going to change to retract tool along the tool contact line. Check surfaces. And I'm going to select whole 3D model. Triple click. Okay. And I want second strategy as well, with the all parts of the tool, so flute, shoulder, shank and holder all selected. And I will use only check surfaces. And again, I'm going to select the whole 3D model. I'm gonna leave all in that unticked. I'm not going to change anything here. Maybe in additional collision, I'm going to add reporting my collisions, okay? So I want to see if there are any collisions. I'm going to remaining collisions, just trim, colliding contours and relink. In linking, I'm going to retract in machining direction. And I'm going to change the large gaps to direct as value, and let's say 2 mil. Also, I want to add roughing cut, so I want to add actually finishing cut. So I'm going to use one pre-finishing path and then one finishing. Okay, and I'm going to add sorting options for roughing, plus leave those settings as standard settings. I don't want to translate, I don't want to have any feed rate control zone. This is okay. And let's see the toolpath. And as I mentioned, we will come back here and we will have another settings, more settings. So let's check our toolpath. Okay, so no collisions found, which is good. And this is our toolpath. Look at this. This will give us a really nice finish. Okay. So it's a pre-finishing pass and finishing pass. That's great. Okay, so now I'm going to copy that toolpath and I'm going to select the other side. Copy after, parameters, and what we need to change. Are those two things. Okay, machining surfaces. And I want to cut now everything on this side. and the small face here and on the other side as well. Okay. Everything selected. Press enter and now drive curves. Okay, and it's the same situation. I'm going to go from here around and finish here. Okay, and my pattern 2, I'm going to select this tiny line here first, so it basically matches the shape. And to that point here. Okay. Click OK. And let's regen the toolpath. Oh, and also I mentioned when we go back, we have extra settings for point distribution, okay? And I want my maximum distance to be 0.1. So it'll be 0.1 between each segment of the toolpath, okay? So that will improve the quality of the surface as well. And this is our second. Okay, that's really cool. Okay, so this is our toolpath. Nice. We've got our part almost finished. So with our next toolpath, I'm going to drill all the holes using 5-axis drilling toolpath. So let's go to toolpaths and in the 2D section, select drill. And we are going to drill those holes around. So there are different depths, different orientations, and I selected all holes by clicking on the wall of each hole. And as you see, they are all the same size. Okay. So now my tool, 11mm drill, my cut pattern is going to be peg drilling, and let's leave 5mm. Tool axis control, I'm going to change that to 5 axis. Okay. In the linking parameters, I'm going to select option calculate internal values from holes and lines. Okay. Top of stock, I put 0, 0, retract 10, tip compensation, yes, 0, safety zone, I'm going to use safety zone because I don't want to hit the parts during the transition from one area to another. 5 axes, define shape, and this is the shape. Okay, I want to use cylindrical, and I'm gonna alter that to 60 radius. Okay, this is my clearance area. Okay, my safety zone. So all the passes will be outside this area. And let's have a look at our toolpath. So my planes are top, top, top. Okay, and this is it. Okay, all looks good. Okay, last operation in our tutorial is going to be DEBURR. Navigate to Multiaxis gallery. In application section, select DEBURR. And as a tool, I'm going to select 3mm ball nose end mill. From cut pattern, my part surfaces, I'm going to triple click on the 3D model to select the whole 3D file. Edge definition, I'm going to change that to user defined. And in user defined edges, I'm going to show Mastercam what sharp edges I want to deburr. Okay. Oh, more. I need more of them. I want to machine also holes. So let's select each hole. Okay. And the other side. And also I'm going to break edge on those sharp edges here on the front. Okay, this looks good. Okay. Okay. And now I don't want to use any check surfaces. My break edge is 0.1 on the drawing. So I'm going to change edge shape to constant width 0.1 millimeter, and in the tool axis control I want machining type to be 5 axis simultaneous, and in the strategy I'm going to change it to normal to contour. But before we change from the fixed to main axis, I'm going to change direction to X axis, and now I'm going to switch back to normal to contour. And in the tilt range, I'm going to change maximum tilt to be 100. Okay. And in the linking, I'm going to set my standard clearance area for this part. 70. Okay. And also I'm going to change the feed distance, air move safety distance, and rapid distance. Okay, and 10. Okay, let's see our toolpath. Yes, this looks good. This is what I wanted. Okay. Okay, let's select machine simulation. I'm going to use Integrex, 150 offset, For the position, use Mastercam stock definition, and the post settings, I'm going to use solution 1. I want my spindle to be on the top, machine part from the top. Okay. Alright guys, thank you for watching the tutorial. I hope that you found this helpful and useful. If yes, please hit the like button. And I get a lot of emails from you guys, and thank you for those. And also please understand that with the amount of emails, I don't really have always time to reply straight away. However, I'll reply every email. I'm trying. And also I receive a lot of 3D models asking for tutorials on particular parts. Some of you guys ask me for help with programming, and as I mentioned, it's quite a high volume and I'm not always have a time to program all those things for you guys, but I always reply and always trying to advise or help. You asked me guys also about some projects and fixture making and other stuff like 3D milling, and even in the tutorials about simple 2D 3D toolpaths, 4-axis toolpaths. Actually, it's quite a lot about 3D and 4-axis type of work, which we'll be doing in the near future. And also a lot of questions about accelerated finishing, how to set it up, what tools to use, how do I know where to use what. And we will be talking about this in the near future. As well, quite a lot of people asking for the triangular mesh kind of toolpath, which is a mixture of 3, 4 axes and 5 axes. I'll try to do a tutorial. It is a really big toolpath and there's a lot of things to explain, and I'll try to maybe do a series only about how each section or method of machining in triangular mesh looks like, and go through all the settings. Alright, thank you guys for watching, and it says a lot of people watching that are not subscribed to my channel, so if you guys regularly watch my videos, please subscribe, and thanks, and see you in the next tutorial. And I'm going to do short video of the sneak peek from Mastercam 22 part 2. So stay tuned and see you in the next tutorial or next video.